Hey guys, today we're going to be talking about simplifying square roots. Now, if you have the square root of a perfect square, the square root of 16, square root of 25, square root of 36, I think we all know how to do that pretty well. At least our calculator does. So we're not going to be talking about problems like that. Numbers that if you just type them into a calculator get you a nice old whole number. We're going to be talking about problems like this, the square root of 80 and the square root of 150. Because the deal is, numbers like this, if you put them into a calculator, are going to get you some crazy, never-ending, irrational decimal. Nobody wants to deal with those, especially mathematics. And kind of standardized math says we don't want to write them as decimals like that. We want to write them in a simplified form, in kind of their, most basic form, if you will. So we need to know how to simplify them, how to write them a little bit better than this. To do that, we always begin by making a factor tree, something you might not have done since you were in 5th grade or something. But let's remember how to do it. You take a look at the number under the square root, and you ask yourselves what numbers could multiply to make this, or what numbers are some factors of this. Well, to me, factors of 80 seem like 8 and 10. Now you could say 40 and 2, you could say 20 and 4. No matter what you do, you'll always get to the same answer. And we keep making factors as long as the number isn't prime. We want to get it all the way down to what's called its prime factorization. So 10 has factors of 5 and 2. 8 has factors of 4 and 2. And then 4 has factors of 2 and 2. So we've factored this all the way down. We have a big factor tree here, right? Now, simplifying radicals says we only want to look at the prime numbers. Those are the only ones we care about. So if you can mentally just kind of block out the others, great. If you have trouble looking at that and blocking out the numbers that aren't prime, then I would say just go in and cross out numbers that you continued to break down so that we only see those numbers all the way at the very bottom. Now, what we want to find when simplifying square roots is pairs of numbers among these prime factors. And anytime we get a pair, I like to circle. I like to make sure they stand out a little bit. So I'm going to see I have a pair of 2's here. Perfect. And then guess what? I also have a pair of 2's right over there. I have one number all by itself, though. And I'm also going to denote the numbers by itself. Now, while I circle numbers together, I like to take a different color and put like a box around those ones all on their own. Because here's what happens. To simplify it, to rewrite it, we write our square root still, and underneath the square root goes any numbers without a pair. So again, any numbers that do not have a pair stay under the square root. So in this case, that's just 5. Any numbers that do have a pair go to the outside of the square root, over here. Now here's the key. Even though it is a pair of 2's, there's 2 of them there, we only write one of them on the outside. They kind of have to team up and combine to get past that square root, right? So this pair is going to get a single 2 written on the outside, and then this pair is going to get a single 2 written on the outside. So we're taking one number from each of those pairs. Now you may be thinking, okay, 22 to the square root of 5? Not quite. This actually means whenever you have multiple numbers, whether it be on the outside or multiple numbers that have to go on the inside, they multiply together. So this actually says 2 times 2 to the square root of 5. So 2 times 2 gets us 4. And then the square root of 5 stays the same. And this is our fully simplified answer. This states, a lot of people will say it 4 to the square root of 5. I tend to say it that way as well. But what it actually means is 4 times the square root of 5. Like a whole number 4 that is multiplying a square root. If you were to type this into your calculator, or if you were to type that into a calculator, you're going to get the exact same answer. But the fact of the matter is, mathematically, we would prefer to write it like this, because sometimes we can simplify those whole numbers on the outside, or maybe we can combine with other radicals or square roots that have a base of 5. Let's go ahead and solve one more before the end of the video here. Square root of 150. Well, I'm going to start by breaking this down into my factor tree. First thing I see is 15 and 10. And then 15, I think, well, that's going to break down into 5 and 3. And 10 is going to break down into 5 and 2. So I ask myself, do I have any pairs? Well, I do. I have a pair of 5s. Again, I forgot to mention, but if you like to block out those numbers that aren't prime, that aren't all the way at the bottom of the tree, you can. But we have a pair of 5s, and then we have a couple numbers that are all on their own. We have a 3, and then this 2. So whenever we rewrite our square root, what goes under the square root? The numbers without a pair, the numbers all by themselves. So I'm going to put a 3 under there and a 2 under there. And what we say numbers do, whenever we put multiple in one place, they multiply. Now we also have to ask what goes on the outside of the square root, and that is a number from our pair, or pairs. In this case, it is a 5. So let's go ahead and simplify this, do that multiplication. 5 stays the same because it's only number on the outside, and then we get 3 times 2, or 6 on the inside. So our simplified version of the square root of 150 is 5 to the square root of 6. Sometimes you may end up with a square root where you only have pairs, no numbers on their own. That means it probably was actually a perfect square and you didn't realize it. You also may sometimes end up with a number that you don't have any pairs at all. And that means the number's already in simplest form. A quick example of that is something like the square root of 55. Well, that only breaks down into 5 and 11. It doesn't go any farther. Those obviously aren't the same number. We don't have a pair. In that case, that just is simplest form. Nothing else we can do about it. It doesn't happen often, but it can come up. If you have any questions about this or any particular square roots that are giving you some trouble, feel free to drop them in the comments below and I'll help out however I can. Thanks for watching, guys. See you next time.